Hi, in this lecture we are going to talk about the linear probing implementation of the dictionary data structure in Python, and of course we are going to talk about the put method, so how to insert key value pairs. We are going to talk about the get method, so how to get the value from a dictionary if we know the key. But first, in this lecture I'm going to talk about the hash function. So the hash function is going to get a key, whether it is a string, for example, Kevin, or a given sentence, this is the key, or for example, just an integer, for example, 100, and it's going to transform that given key into the index of the array slot. This is how associative arrays and dictionaries work. Okay, so we can define our own hash function. What's important that we have to make sure that we are going to transform this given key into array indices, because we are going to store the data, the key and the value pair in one-dimensional arrays. This is what we have been discussing in a theoretical section, that the underlying data structure for a dictionary is going to be a one-dimensional array, because we are able to achieve order 1 constant time complexity whether we insert some data or retrieve some data because of the random access feature of arrays. Okay, so we are going to talk about this function, and let's take the example apple. So if the key is apple, we should take this string and we should transform it into an array index. So we can define whatever hash function we prefer. What's important that it should return an integer, the index of the array slot. So an intuitive approach is that we can have the ASCII values for the characters, because as you may guess, computers store these characters as integers, and of course computers store integers as binary numbers. But what's important that we are able to transform this string on a character by character basis. We just have to take the ASCII values of the single characters. What's the ASCII value for the character A? It is 97. What's the ASCII value of P? It is 112, then 112 again. What's the ASCII value of L? It is 108. What's the ASCII value of E? It is 101. Basically, you can search for the ASCII table on the web, and as you can see, every single character and integer, exclamation mark, plus, minus, dot, and so on are associated with a given integer. As you can see, lowercase a is 97, b is 98, then 99 is c, 100 is d, and so on. So this is the ASCII table. We are going to get the characters out of the string, and we are going to transform it into ASCII values. Then we are going to sum up these integers, but it's not going to work fine, because if we have an array for 10 items, of course the index 530 is not going to work fine. It is out of the scope of the array. So we have to normalize it with the size of the underlying array, and we have to transform this integer within the range 0 and size of the array -1. And basically this is what's happening here. We get the key, we are going to have a sum, we iterate through every single character of the key, and we are going to take the ASCII value. This is going to transform, A is going to be transformed into 97, then B is going to be transformed into 98, and so on. So it's going to transform characters into integers. We are going to sum it up, and we use the modulo operator, because if we have an array with size 10 and the sum is going to be 11, it's not going to work fine. It's going to be an array out of bound exception. So if we use the modulo operator with the size, it's going to be 1, which is going to be a valid array index. If we have, for example, 22 modulo 10, 22 is not a valid array index because the size of the array is 10. But if we use the modulo operator, it's going to yield 2, and 2 is a valid array index if the size is equals to 10. So this is what we are going to use as a hash function. Why is it good? Because we are able to transform keys into array indices with a very simple hash function. Okay, it's not going to be the best possible. We should use several prime numbers in order to avoid clustering, as we have discussed in a theoretical section. But it's going to be a good guess at the beginning. We just want to have a good understanding how linear probing implementation works. So basically this is the easiest hash function we can construct. Okay, so that's all about the hash function. Thanks for watching.